Okay, this video is going to help you out with the topic binomial problems basic. So we'll look at a couple of examples. The first one I'm going to go into some depth, and then by the second one I'll show you the formula and how we can kind of basically get through it. So in this first example, it reads, not all visitors to a certain company's website are customers. In fact, the website administrator estimates that about 10% of all visitors to the website are looking for other websites. Assuming that this estimate is correct, find the probability that in a random sample of 4 visitors to the website, exactly 2 are actually looking for the website. Round your answer to 3 decimal places. So we want to find the probability that 2 of 4 visitors are looking for that website. That's like the probability that I'd like to find. Let's do this. Let's call S a person looking for the website, as in like a success. I would call that outcome if we pick one of those 4 visitors and that person is looking for the website. Let's call that a success, because that's what we're trying to find the probability of, like 2 of the people are looking for the website. So I'd say like we're looking for 2 successes defined as a person looking for a website. So S is really for a success. Okay, and let's let F be a person not looking for that website. And the F is for failure. So if we pick one of those people and they're not looking for the website, that would be considered a failure of an outcome. Now, we have to try to figure out the probability that 2 of 4 visitors are looking for the website or are a success. So I would imagine you would agree with me that one possibility would be, of the 4 people, we have a success, and a failure, and a failure. So now it could turn out differently as far as, there's other possible combinations of how this could have turned out. It doesn't necessarily have to be the first 2 people were successes and the second 2 were failures. It could be that, we had like a success, a failure, a success, a failure, or a failure, failure, success, success, and so on and so forth. So there's lots of different permutations of how this could work out. So let's do this. Let's just focus on the one for the second and try to see if we can calculate just in this one case, let's say, and not worrying about these other ones, how we can calculate the overall probability here. Well, I think you guys would agree that the probability that we have a success, so the probability of a success, or an S, is, let's see, it tells us here that 10% of all visitors are looking for other websites. So that's actually the probability of a failure, right? Those are the people looking for other websites. So let's start actually with that. The probability of a failure, F, is actually 10% or 0.10. That's kind of what they're telling us. So I'm going to start with that, the probability of a failure. That means that the probability of success is the complement of that. In other words, if you took 100% and subtracted the 10%, or you did 1 minus 0.10, that's going to give us 0.90 or 0.9 as the probability of success. So if 10% of the people are not looking for the website, that means 90% are looking for the website. So that's the way I'm going to calculate my probabilities of success and failure. So I think you guys would agree, if we look at just this example here, the probability of this guy being a success is 0.90 or 0.9. The probability of this success is also 0.9. Again, these are independent. Just because this guy was a success doesn't mean he's less likely to be a success. It's still 0.9. The probability of a failure is 0.1. The probability of a failure is 0.1. In other words, I have 0.9 squared times 0.1 squared, and that would be my probability of just this particular instance. But remember, there was other possible combinations of how 2 out of the 4 visitors could be looking for the website. So for each one of these, now by the way, just for giggles, just to show you that all these would be the same. If we did this one, it would still be probability of success 0.9, probability of failure 0.1, a success 0.9, a failure 0.1. If I multiply in a different order, there's still 0.9 squared and a 0.1 squared. For all the different possible combinations of picking 2 out of 4 successes, each one of them would have the same probability. So I would have to multiply all those probabilities together. Well, so what I would say is let's figure out how many, let's just try that again, how many ways to choose 2 of 4 visitors as a success. Well, that would just be 4 choose 2. If I have 4 objects and I'm choosing 2 of them, that's all the different ways I can select those 2 objects. So there's going to be that many ways of getting 0.9 squared and 0.1 squared options. So this is actually my answer. That's going to be my calculation. So you can use your Alex calculator, of course, but I'm going to use this one and do 4 choose 2, and then multiply that by 0.9 squared and 0.1 squared. And I get to 3 decimal places, 0.049. 0.049 would be my probability there. Now, I'm going to show you a little bit faster of a way of getting that formula. So let's do real quick in general. So this is super important here. I think this is going to be the most helpful way of thinking about it. If you have n independent trials of an experiment and each trial has a probability P of success, and therefore 1 minus whatever that probability is would be 1 minus P would be the probability of failure, then the probability of exactly, let me call it S successes out of N total trials would be the following. So do you remember how in this one we did the total number of trials, which happened to be 4 people, and there was 2 successes? Well, here there's N trials. We're going to choose S successes. Then we just have to multiply that by the probability P of success raised to the number of successes S, and then the probability of failure is the complement of that, or 1 minus p, and then raised to the number of failures, which would be n minus s. So all this is the number of failures. Failures. So let me show you how to apply that into the next problem, and I think you're going to see it's not that bad. So the workers' union at a particular university is quite strong. It says 96% of all workers employed by the university belong to the union. Recently, workers went on strike, and now a local TV station plans to interview 5 workers chosen at random at the university to get their opinions on the strike. What's the probability that exactly 2 of the workers interviewed are union members? Okay, so let's figure out, if I'm trying to use this formula, n c s, or n choose s, p to the s, and then 1 minus p to the n minus s. Okay, first off, n is the total number of trials. In this case, I would say that's the total number of workers being interviewed. That would be 5. So n is going to be 5. The number of successes we want, it says right here, we want a probability that exactly 2 of the workers are union members. So s is going to be 2, and that's union members. So then that means that the probability of a success, p, remember p is the probability of a success, the probability that they're a union member is 96%. It says right here about 96% belong to the union. So the probability of success, they give it to us, it's 0.96. That means the probability of failure, 1 minus p, is going to be the 0.04, right? 1 minus 0.96. And so I think we have all the information we need. It's just going to be 5, choose 2. The probability of success is 0.96, raised to the second power, because we want 2 successes. The probability of failure is 0.04, and raised to the number of failures, or you could do 5 minus 2, right, would be 3. Again, there was 5 total. If I take away the 2 successes, that means there's 3 failures. The way I remember it is I just have to find all combinations of the total, choose how many successes, probability of success to the number of successes, probability of failure to the number of failures. I mean, that's it. So this would be the setup for that one. So actually not that bad once you get the hang of it. I hope this helps you. Thanks for watching.